Welcome to the first of a three-part series titled Top 3 Material Management Secrets of Successful Lean Professionals. I'm Richard Rahn with the Leonardo Group, and if you're like me, you're probably pretty busy, and it's tough to allocate the time to watch long videos online. So with that in mind, I'm keeping each of the sections, each of the parts in this series short, under 10 minutes, so that you can actually take the time to watch them and absorb the content in small chunks. So let me start with a brief introduction to the Leonardo Group and myself, and then we'll get right to it. By the way, this is unscripted, so if I go off script occasionally or make an occasional bumble, then you'll appreciate why, and hopefully forgive me for that. So let's get going. At the Leonardo Group, we've been doing lean training and mentoring since the early 1990s, so over 20 years. And all of us started our lean work first in manufacturing. That's very common. But it turns out that lean's also great for hospitals, and so we started our first lean hospital projects in 2002. Now, we currently have over 20 lean consultants in the company, in both our U.S. office and in Munich, Germany. And I mentioned multilingual and multicultural here since we have Leonardo Group mentors from a variety of different countries. And we do what we do in over 8 languages. Now, we're the authors of the book, The Complete Guide to Mixed Model Line Design for Manufacturing, and also 6 books for the Lean Hospital, available from flowpublishing.com, quick plug here, our online bookstore, or amazon.com, and they're available in paper or in ebook formats. And we're currently partners with Toyota Material Handling, and we periodically teach workshops at their fork truck plant in Columbus, Indiana. More on that a little bit later, and on this web page down below, you can click on a link and find out more about that. Now, material management is near and dear to me, as I'm a former material manager for an aerospace company here in Colorado where I live. Also earned my CPIM credential, which some of you listening may also have from APIX. Been a 100% full-time lean consultant and trainer since 1994, involved with it prior to that time, but full-time since 1994, and with a lot of that time, so what is that, 21 years, dedicated to material management projects of various types. And finally, I'm one of the main developers of the 3-day Lean Material Management course or workshop that we're teaching at Toyota, and we're also teaching this course to many other Fortune 500 companies today. So, that's me. In the words of John Lennon, I hope I pass the audition. Now, we're using the word secret in our title, and using that word is intended to get your attention. But in fact, there are different kinds of secrets. There's what we might call a real secret, and there's what we might call a self-secret. So a self-secret is something that's right in front of you, but you can't see it. You've seen those kind of graphics where you just shift your field of vision and the old woman turns into a young woman wearing a hat, those kind of things. I'm sure you've seen those. That's kind of what we're talking about. So imagine you're looking out of a window, picture window in your house to the outside world. You see your garden outside and trees and the wind blowing. And you realize that you can also, if you just shift your focus of attention, you can also see yourself reflected in the window, like a mirror. So exactly like you see in the picture shown here, little girl. So you try to explain that phenomenon to another person, and they don't get it, and they keep looking through the window. But once you get it, or once they get it, it becomes obvious, and then you can do it again and again. You can kind of shift your attention and shift between seeing yourself in the mirror window or shift your attention to the outside. So that's what we mean by a self-secret. And why are we using this as an example? Because some of the issues that we're going to discuss in this course fall into that category of self-secret. But once you get it, hopefully you won't forget it either. So let's start by defining success as it applies to the world of lean material management. In other words, if we achieve these goals listed here to a high level, then we can declare ourselves, at least for a brief moment in time, successful in lean material management. Now, many of these goals listed here are what we call North Star goals. That means we don't expect to actually get there or achieve them, but they provide direction. They're the direction in which we are sailing our ship with the sextant and looking at the stars and looking at our clock and kind of figuring out where we need to be. So that's a North Star goal. For example, the first one, zero shortages. We don't actually expect to achieve zero shortages other than, as I said, maybe for a brief moment in time, but that's the direction in which we want to travel to achieve lower and lower or fewer and fewer shortages of materials. Next one is high inventory velocity or inventory turnover. So within reason, higher inventory turnover is better. Now you could imagine, I suppose, a case where you're turning inventory too quickly and you're causing other unintended or intended consequences, negative. But in general, higher inventory velocity means lower inventory investment, lower working capital investment, while supporting the same level of production as before. So higher inventory velocity is a worthy goal. Now, what should it be? What should our inventory velocity be will depend in large part on our industry. So automotive inventory turns is a different environment, different expectations for inventory velocity or turnover than, say, electronics or, say, aerospace. Aerospace is definitely going to be slower, lower turns, and maybe electronics is somewhere in between with a lot of components, and maybe automotive is on the high side. But in any case, it's going to be very industry specific. And I think the important point with velocity is that we show continuous improvement, not so much set a hard numeric goal to achieve. Third point for success, minimal NVA or non-value added work or efficiency. That means we design our material delivery system, material replenishment system to operate with a minimum of waste, doing things that don't add value to the function of delivering materials, like excessive motion, for example. Third one is accuracy of data. We're going to talk about this first, the need for data, what kind of data, and what we mean by accuracy. But certainly when we're managing hundreds or thousands of components, then we can't be doing this by hand. And we need to rely on computers, and computers, of course, rely on data. So successful material management implies that we have control of, we know how to manage data accurately, information about all the items that we're managing. And then, of course, it kind of goes without saying that we need to be able to sustain all this over time. We can't declare ourselves successful if we've achieved these things for just a few days or a few hours. We have to maintain this and sustain this over a long period of time before we could really declare victory on this issue of success with lean material management. So this is what we're shooting for. This is the direction in which we're traveling. And now let's take a look at the three main topics in this three-part course. So here are the three topics we're going to cover. And we will address the first one in this particular segment, and then we'll look at 2 and 3 in following online videos. So we can break this down into smaller pieces and not make this too lengthy. There's a lot to talk about with each of these. So the first main topic that we'll address in this particular video is merging lean and ERP or MRP methods. How do we do that, and what are we shooting for when we combine those two? Second main topic, this will be video number 2, is using lean tools for material delivery, design, and management. This is an issue that I think a lot of lean practitioners don't fully appreciate, the relationship between delivery routes and the target amount of inventory we want to manage in the system. And this is the key to zero shortages, is designing your delivery route frequency in correlation with the amount of inventory that you're planning to stock on the line. So it's a key to zero shortages plus, at the same time, achieving high inventory turnover. So this is pretty critical. And then the third one is the people side of lean material management. And what we're talking about here is, some of the misconceptions about lean and continuous improvement and quality circles and those kind of issues. We do need to engage our team, our material delivery team, but what are some of the things that we need to focus on to do that successfully? So highly important subject. Lean, by the way, is a highly people-centric kind of initiative, so we can't leave this out of a main topic for our subject at hand. Okay, with that, let's jump right into the first one, merging lean and ERP MRP. So why are we even talking about this? You might be asking yourself, why even include this as a topic? Well, in the past, maybe somewhat distant past, there was a misconception that somehow lean was very manual, especially when it comes to material delivery systems. So we have cards, paper cards and labels and empty bins, and we don't really need to use, in that environment, an MRP system or computer-based material management system. And in fact, I guess guilty as charged. In the past, I'm saying more like 10 or 15 years ago, we would actually counsel our clients that when it comes to shop floor management of materials, you basically can turn off your MRP system. You don't need it. Maybe you still need it to procure material from the outside with outside suppliers, but on the factory floor, the method of choice is Kanban, and the Kanban system is going to run independent of MRP. Now, as time has gone on and experience in this area has grown, we have discovered that this is not exactly true, or not true at all. So let's explore what we mean by lean plus MRP in a little bit more detail. So the first thing we want to do is disavow of this notion that you can get along without an MRP or ERP system. You need one, especially if you're a company of any size. Of course, if you're so small that you can manage things in a spreadsheet, that's a different kettle of fish. But if you're a larger company where you're managing hundreds or thousands of components from suppliers across the planet sometimes, from China and Indonesia and Vietnam and US and Mexico and you name it, Europe, then you need to have a system to help you manage that, and that's what we call MRP or ERP. In fact, MRP, the original meaning of the acronym MRP was Material Requirements Planning. Back in the, I don't know when that was, 60s, 50s, 60s. In fact, some people have accused, I'm going off track here, but I may as well, it's too late now. Some people have accused IBM of originally developing MRP as a rationale for selling computer hardware, because it was so data intensive that if you committed yourselves to using MRP, you needed to buy big IBM mainframe computers to run it on. Well, that makes some sense. That could be. That's not entirely irrational, an irrational thought. But these days, of course, computers are a lot faster, and that's no longer really an issue. But the question here then is, how do we integrate MRP, the computer-based material management system, with techniques and methods like Kanban? So let's get into that. So certainly there's something attractive about Kanban methodology, very visual, very immediate, real-time. So you consume material, and when the bin is empty, that's the signal, and you refill it, or you send a card back to the Kanban supermarket for replenishment, etc. There's something very attractive about that. But there are some definite weaknesses to the Kanban method, especially as we get into this world today of mixed model manufacturing, or industries like aerospace and high mix, low volume kind of job shop kind of environments, where the Kanban method starts to break down. So it's going to break down in a couple areas. One, and they're listed here. So the first one is the Kanban system is weak when it comes to managing changes in usage due to changes in mix. So if we're building the same product over and over, there's no change in mix, and the consumption of parts is going to be very level. But if you're mixing different products with different components, different materials, and that mix can change from day to day, then our Kanban system, which remember is a fixed quantity kind of system, is at risk of actually running out of parts. If the mix is unfavorable on any given day, you could actually overrun the Kanban system's ability to replenish within the planned cycle time, replenishment times. So that is a risk that we're concerned about. Next one, changes in revision levels. Again, because we're not issuing material directly to a work order, we're stocking material essentially at the point of use, right, on the line. then if we have an environment where we have frequent engineering changes, frequent revision level changes, like aerospace, for example, then we run this risk of losing control of that, given the fact that we're not actually issuing material to a specific product. That material is out there in a bin. So that's, again, it's not something we can't overcome, but it is something that increases the risk factor of a Kanban system. Third point, changes in demand. So overall demand, not just mix, but overall demand. Again, as demand goes up or goes down, well, if it goes up, we could actually overrun our ability to replenish on time. And if demand is going down overall, then we could have excess inventory. Our inventory turns are going to be negatively impacted. So again, it's not something that we can't manage, but we have to be cognizant of that. And as overall demand changes, goes up or down, we're going to have to resize and reevaluate our Kanban system, sometimes more often than we would like. Number 4, lost or delayed signals. Remember, Kanban is essentially a manual system, relying on cards, lights, signals. Could be electronic, but usually that electronic signal is initiated by a human being. So it's manual from that point of view. And if those signals are either not issued at all, or they are delayed, or if the signal is a physical card or a physical bin and that bin or card is lost, then the signal is not received. This is a concern. In fact, many times when people say, we tried a Kanban system, but it didn't work, what they really mean is not that the Kanban method doesn't work. They meant that they didn't have the internal discipline to maintain the system, that people weren't actually submitting the cards properly. Maybe they weren't trained properly. So that's what we mean by number 4, lost or delayed signals as a weakness. So it's not bulletproof. It relies on human beings. And the last one, which is pretty important, given mix changes and given demand changes, is that Kanban doesn't really have very much future visibility inherent in it. It's a fixed quantity. Sure, you can change the quantity when things change, but how do you know that they changed? So you'd have to have some other way of knowing. Kanban by itself doesn't really have any idea of what's coming down the pipeline in the future. It's something based on an assumption of volumes and mix, and you do the Kanban calculations, and those calculations may be accurate for today, but things can change radically over time, and Kanban inherently doesn't know that. So we want to be able to respond to that. So those are the weaknesses we want to try to address when we move forward and talk about maybe using the tools we already have in the form of ERP and MRP to help us out in managing all of these issues. Now, having said that and kind of dissed the Kanban method, let's not throw the baby out with the bathwater, meaning let's not just abandon Kanban altogether and say that, gee, this isn't going to work. Let's just go back to pure MRP. That's not a solution either. In fact, let me say this. Companies that are pure MRP driven when it comes to their material management systems, I haven't seen too many of those that really have done a great job of managing inventory turnover, that have high turns, that have zero shortages. I just haven't seen a model of excellence. And that goes back to the theme of this whole topic, that the models of excellence that I've seen over the 21 years of doing this kind of work, the companies that I could point to as being excellent, including this car manufacturer that begins with a T in their name, tend to run a hybrid kind of scenario where they are using Kanban, but they're also merging that or integrating that with automated computer systems. So that's the direction that we're going and that we're going to explore in just a second here. So let's not throw the baby out with the bathwater. We're still going to use Kanban, but we need to use it correctly and supplement it with other tools. Okay, hope you're with me so far. Hope that makes sense. Now let's look at an actual case history of what I'm talking about here and how that might work. Okay, so here's an actual case history, or I should say, here's an actual material replenishment system, and I've broken it down into discrete steps, and then I've labeled each step as whether it's a Kanban step or an MRP step. And this is actually, I don't think this is a secret. This is how actually a lot of companies do it, but this is an actual example taken from Toyota Material Handling in Columbus, Indiana, who, in my opinion, are kind of a gold standard for what we're discussing here and have achieved high turns plus low shortages, plus high efficiency, all of those things that we talked about as being goals for our lean material management system. So let's start at the top here where it says pull card. I'm just going to walk you through the steps and you can follow along. So pull card, this is an operator at a workstation. In fact, it's a little more sophisticated than I'm showing here, but basically a card would be pulled from a material bin. And there might be 2 bins of the same material or 3 or 4. It's not, strictly speaking, a 2-bin methodology, but they have a bin. There's a card in the bin, and as a part, the first part is taken out of that bin, the operator will also take the card that's in that bin out and place it in a collection box. And that's the child collection box. There's also a parent collection box, which is used to consolidate the cards within an area so that the pickup person, the material handler that comes by pretty often, doesn't have to go roaming around the entire floor to pick up cards. They're consolidated into a master box that's along the aisle. So the material handler can go by, and every material replenishment cycle, these cards get picked up. And by the way, they have a pretty cool way of making sure that those cards are waiting. They really follow up very real time to make sure those cards are collected by the team leaders or assistant team leaders in the area and put in those boxes every replenishment cycle. So that's the pull card. Now, deliver card, the material delivery person who's typically driving a tugger, train, will come by pretty often and pick up a stack of cards, and then as part of a normal delivery route, not a special trip, part of a normal delivery cycle, will bring those cards over to a scanning department, scanning station. So both of those steps, pull card and deliver card, are manual so far. It's an actual piece of paper, with a barcode on it and the information, etc. Now, here's where the computer system comes in, and this is pretty cool. So step 1 is scan card. So there's a scanning station. It's a centralized responsibility. We don't have operators actually scanning cards at workstations. We don't want them to be spending their time doing that, actually. But there is a person responsible in a scanning station to scan the cards into the computer system. And in fact, each card is serialized, has a unique number on it. So it's possible for the computer system to track individual Kanban cards. And actually that's extremely helpful because now the system can know if an individual card hasn't been scanned in a certain amount of time, and that's a red flag. Why not? Where is it? And that would be an alert. That would be a signal to go out and find it. And so auditing the Kanban system is actually part of this overall strategy. So scan the card electronically. That data, that card information is now in the computer system I'm calling MRP. Some of this is home-built algorithms and functions, apps, if you will. Computer programs that do this kind of analysis may not be part of the original MRP system, but it is now. Now, the blue button here, process data. Once the information's in the MRP system, process data. Now, this is the cool part. This is the secret sauce part right here. So process data means let's look at that card and not only reprint it if necessary. They don't recycle the cards, by the way. They dispose of them. But we may not just automatically reprint a card. First, we're going to look at essentially the MRP output for future requirements. And based on some algorithms, some rules, we're going to determine, we meaning the MRP system, whether or not the card can be reprinted or whether we want to actually increase and print 2 cards, in other words, a whole nother tote or a whole nother bin of material because we see demand for this item going up. Or if demand is going down, maybe we hold or put the card to sleep for a certain amount of time. Or maybe it's even now an obsolete part and we remove it from circulation. So there are a number of rules that get applied here by the computer for every card that gets scanned. And that is pretty cool. And the data, the primary data it's relying on is standard MRP data where you have a time phase plan of usage or of consumption that MRP will create as part of its inherent, basic capabilities. Now, depending on the application of the rules, then the system will reprint the card in the area. They have various areas where parts get picked for replenishment. It'll reprint that card in the area that will be actually pulling those parts. It's not always the same area, but the card gets physically reprinted. Now we're back to manual. So the new cards get picked up at the printer. In each of the picking areas, we sometimes call those supermarkets. So it's a Kanban supermarket, and a human being is going to find those parts, look at the card, determine the quantity, the part number, etc., and the bin type, and pick those parts and put them on a tugger train waiting there in that area, waiting for the next delivery cycle. And then to close the loop, we have the delivery cycle where the tugger driver will, on a very, very frequent and fixed route, pick up the trains and deliver those bins back to the stations, back to the points of use. And that Kanban card is now back in the bin, right? So that closes the loop on the cycle. Now, the beauty here is, as I alluded to just a minute ago, is that if there are exceptions, for example, demand going up or down, then the cards may or may not get reprinted, or more than one may be reprinted. But also, if a card is missing, and the system will know that because they'll, based on certain rules, within a certain amount of time, if that card exceeds the expected time that bin should have been going through the system, cycling, that there will be a report or an exception report or an alert, and people will actually go out and try to physically find those bins and those cards. And that way the system is being maintained on a daily basis or routine basis to make sure that everything stays in sync and that things are not being not falling through the cracks. So it works beautifully, but again, it's the marriage of manual methods and MRP that make it so successful. Okay, so here's another example. In the previous one, we talked about Kanban and MRP hybrid or combining those. But here's another case, different, where we have 100% MRP. So imagine there is no Kanban. So there's no signal. There's no Kanban card, and we're relying on our computer system 100% to issue the material or identify a requirement for material that's needed on the factory floor. So what are the problems with that? This is 100% pure MRP. Well, one concern is that MRP is not real time. So depending on the frequency of updating the computer system through the form of, say, a backflush transaction, the computer system may not know where things are. Kanban is pretty much real time, isn't it? When I'm out of a part or when I pull a card, that's an operator doing it in response to an actual physical action. But a computer may not have a transaction at that point. The transaction may not happen until much later. In fact, in some factories, it may not be for hours or days later. So the computer system is not going to know that. So not being real time is a concern, because what you could find yourself doing, or what the MRP system could find itself doing, is issuing material not needed or issuing material late if it doesn't know what the actual shop floor status is. And of course, getting an accurate quote-unquote shop floor status into a computer means a lot more transactions and a lot more points of potential failure. So that is a concern, not real time. That's really one of the big reasons why we like Kanban, is that it's more of a real-time system. Next concern with MRP is data accuracy. Now, with Kanban, whether your data is accurate or not, you pulled the card or you have an empty bin or you have a card. That wasn't dependent on the data. It was dependent on actual usage. But if you're relying on MRP purely, then if your data is off, then your results are going to be off. And the classic phrase that I'm sure you're familiar with is garbage in, garbage out. So data accuracy is a big concern, maybe the biggest concern. And MRP requires data from a number of different sources. It requires a master schedule, it requires a bill of material, it requires lead times, it requires quantities on the bill of material, etc. So that is a big concern that has to be managed. It can be done. Now, a couple tips or techniques if you're using 100% MRP to deliver more than just exceptions, more than just low volume material. are these two tips. Again, this doesn't apply necessarily to low volume parts that I'm only using once in a while. But if you're trying to use MRP without a Kanban system, and why would you ever do that? Well, some factories feel like they don't want to rely on operators to be signaling for material. They want it to be more automated. Now, if you're doing that, a couple different techniques or tips. One, you need to put limits on the push system, because MRP without Kanban or signals is a push system, which is normally not something we like. But if you have a push system, put some limits on it. In other words, you can't keep pushing material onto the floor beyond a certain quantity. So it's like a max quantity. And beyond that, it will not continue to issue material of the same component. So that's one thing you need to have in the system. And probably MRP systems have that capability, like a min-max. So it's the max. And the other thing is fixed quantities. Yes to fixed quantities. So when we move material, it's not in some variable quantity, because then you'd have to be counting out of the warehouse or the supermarket. It would be more efficient, depending on your volume, right? Depending on your particular scenario or situation. But in general, you want to move material in fixed quantities. So you set the container size, you fill the container, and you move it in those quantities. Again, there are exceptions to that. It depends a lot on your environment. But fixed quantities will help reduce the amount of handling, counting, non-value added kind of effort if you can always move the material in a fixed quantity in a predetermined bin. So those are the tips for 100% MRP. Again, we're not recommending that, but we have seen it, and there are sometimes very good reasons why you'd want to do that, especially, as I said, for low volume, low usage kinds of items that are not in the Kanban system. Okay, so I think that's it for this topic. Let's wrap it up on the next slide. Now, you're going to be able to see in action some of the things we've talked about in this video and in the upcoming two sections live at Toyota Material Handling in Columbus, Indiana, September 22nd through the 24th for our Lean Material Management Workshop. That's 3 full days going deep diving into all of these issues and taking 2 plant tours as well, discussing what's happening there. So if this is of interest to you, there are only 32 seats in this really nice but small training facility at Toyota Material Handling. So find out more. I think the complete 3-day agenda is available for your review and a lot of other information by clicking on the link below here and find out more about that workshop. So that concludes lesson 1 of a 3-part series on the subject of lean secrets. And you can expect a notification in the next day or two on how to get access to the second one in the series. So again, thanks for watching, and we'll look forward to staying in touch.